Yeah, yeah, cool. I see a thumbs up there. All right, I'm gonna present my screen. Give me 1 sec. Let's see, I think I see a question or two in the chat. We are recording. Andrew, we're recording. Awesome, great. Sweet, so let's start it up. Today's chat or training session is about plugins. So yeah, I hope you're all in the right spot. Thanks for joining today for our first ever community gardening days for Spinnaker. So who am I? I am a software engineer over here at Armory. I contribute to Spinnaker myself, and I'm the co-lead for the platform SIG. You can reach me at any of these locations, and yeah, feel free to reach out. So when we talk about plugins, let's first go over a few different concepts so that we're kind of all on the same page with what a plugin is, what a few different words we're going to use and like terminology so that we're all on the same page. Cool. So let's see. So for Spinnaker, we're using this framework called PF4J, and let's just take a quick look at that. Let me pull up Chrome so I can show y'all what this framework is. So PF4J is a very aptly named, it's called Plugin Framework for Java. So this is the framework that we've chosen to integrate with Spinnaker. We have a few things that we layer on top of it, but PF4J is the base framework that we've added to Spinnaker. So we use PF4J, and then we use PF4J update quite a bit as well in the delivery aspect that we'll be covering today. So when we talk about PF4J, this is the project that we're going to be referring to. So PF4J has this concept of an extension point within its framework. So an extension point is basically an interface that a class will, or another interface rather, will extend and add some stuff on top of. So in practice, we're going to see what this looks like in practice, but that is going to be a major topic of today is extension points. PF4J provides a lot of nice things around plugins, and some of those things include like isolated class path loading so that your plugin can have different dependencies than another plugin, and extension points in PF4J are a huge help in that regard. Extension points, as we've defined or as we're using them in the Spinnaker project, these are well-defined interfaces that you can build your plugin against, and they're supposed to be long-term stable. The idea here is to lower the barrier of entry so that everyone can kind of hop on the Spinnaker train a little bit easier and give non-core developers an easy-to-use interface to add functionality. Well, let's go back. So an extension is what your plugin will be adding. So your plugin is adding extensions that use, or rather implement, extension points. So a plugin will be either one or more of these extensions. A plugin developer is someone like you or me who is going to actually create a plugin. So that's starting a whole new repo in Git or whatever your favorite version controls system is, and writing your plugin as one contained project. A Spinnaker operator, though, is someone who is they are generally in a DevOps role. They are operating Spinnaker. So they're the ones who are going to be adding your plugin to a existing Spinnaker installation. Please ask questions in chat if you guys have any questions. I'm happy to answer them. Spinnaker users are users of Spinnaker, right? So people who create pipelines potentially, application developers, etc. How they fit in here for our talk today is we're focusing on stages in particular, because stages are the most common way that users interact with Spinnaker. Maybe not the most common, but it's a very important piece of the pipelines. Let's talk about extending Spinnaker. There's a few different types of plugins, so we're going to go through them pretty quick here, but we're going to focus on extension points today. We have a example road project on GitHub that let's check it out. Called Spinnaker plugin examples. So if you guys check out github.com/spinnaker-plugin-examples, you'll see we have a bunch of example plugins here. The one that we're going to be focusing on today, and the one that's used in the Spinnaker OSS docs, is this PF4J stage plugin. This is based off of an extension point, and that's why we're focusing on it today. So again, extension points are long-term stable interfaces, and we'll look at one in a sec. With PF4J, though, we can create a few different types of plugins. So one other type of plugin we've created is a plugin. It's similar to using an extension point. However, there's no guarantee that it will be long-term stable. So you can create a plugin, and this is a great example, based on an interface versus an extension point. Again, an extension point will be long-term stable, so less maintenance over time. If you are interested in creating plugins that do not use extension points, that's like really good to know what types of plugins so that we can then create good extension points there, so that in the future more people can create plugins easily and have less maintenance over time. The third and final and also more advanced way of creating plugins is via Spring. So essentially, we have an Armory distribution of Spinnaker, and what we do essentially, I think everyone kind of does this if you have your own distribution. You pull in the open source project, you add some classes on top of it, and they get wired in via Spring. So you might define some extra beans, some components, some services, and it just works. So we have a way of hooking into anywhere in Spinnaker via Spring, but it's kind of a work in progress, and it's not exactly Spring. If we take a real quick look at what this looks like, there's some work you have to do in terms of registering your beans in a different way than you might be used to. So this is an area of focus right now, and we're trying to clean this up a bit. Again, we're going to be focusing, though, on the extension point today in PF4J stage plugin. Cool, so those are the three types of plugins that you can create. Well, let's talk about backend development. And let's look at this simple stage extension point. So this is a class that's in Orca that, well, it's an interface that extends the extension point from PF4J. So if we take a look at that, this is what it looks like. So we're in the 119 release of Spinnaker, just so that we are all on the same page here. And we can see that simple stage extends this extension point. All it is comprised of is two methods. We have an execute and a getName method. So execute is going to be the bulk of the stage. It's going to take this input and then return status, output, and context. We'll go into what each of those mean in a sec. We also have this method called getName, which essentially just names your stage, so that when your front end is requesting, hey, I want to talk to or send some info to a stage, let me choose a stage to add. It'll appear in the dropdown. see a question in chat. Let's do all the stages need to be in the Orca API package? No, they, sorry, yes, they do. Yes, they do. Apologies, I have construction going outside of my house, so there's a bit of a distraction there. Cool, so this is the execute. Sorry, this is the extension point that lives inside of Orca. So when we want to use the extension point, let's take a look at what the PF4JStage plugin looks like. Cool, so here's our PF4JStage plugin. We'll go over the project structure in a little bit, but for now, we're just going to focus on this module here, random weight Orca. So this is a pretty basic Gradle project. You have your build Gradle file here. We can go over some of the important pieces here, but let's see, as you can see, no, we'll talk about this in the later section about build, sorry. Oops. All right, let's take a look at the class though that implements the simple stage. We go, this is in Kotlin, so if you guys have any experience with Kotlin, it's a pretty cool language. It's similar to Java and includes a lot of nice quality of life improvements. So random weight is plugin .kt is the file that is our main plugin. So we have this plugin like a wrapper essentially, and what it implements this plugin class from TF4J. So what this does is it has a start and a stop method, and this is for starting and stopping the plugin at load. And we'll see how this works in a little bit. We also have the bulk of the plugin, which is our random weight stage. And as you can see, it implements the simple stage class. If you did notice in simple stage, we have a class that you give it as the input. So if we take a look at our random weight input class, we can see it's a pretty simple class, and all it contains is this max wait time. If you guys don't know Kotlin, all this is doing is creating a class with a variable of max wait time, and it has getters and setters associated with it. So this is the input that we're going to be receiving from our front end that says, hey, I have this field, max wait time, and give it an integer. There you go. Might help if we describe what this plugin is doing. This is a random wait stage, so you give it a number of seconds, and it will sleep for a random number of seconds between 0 and that time. As you can see in our getName function here, we just return random wait. So when we see the plugin in our UI, we should see random wait as the stage name. Our execute method has a few different pieces here. We have a simple stage input, right? That was our class that we showed earlier. We have this random wait input is the type of input there. We have to have a simple stage input as the parameter here because we need a wrap. We don't know what the class is that's going to be passed into this execute, right? So you define it yourself. All this method is doing is getting a random number between 0 and that max wait time, and then just sleeping. This is a horrible error. Don't do that, and don't catch like that either. For the output, we're setting up the output class here, which consists of output and context. There's not strong conventions right now around output and context, but output is supposed to contain the information that is returned to your pipeline execution. And context is really information that is relevant in the stage itself. So we have this output class that we assign the values to. So what we're doing here is we're saying, hey, we got the time to wait and we have the max time to wait, and we're going to say the status of this stage was success. A couple more questions in chat. Can you extend stage with stage definition builder, cancelable stage? That's a great question. So this is a pretty simple stage, and what this does is it's pretty simple. It doesn't have any smarts around it. So this was a very, let's say, like MVP type of like, let's get going with adding stages. There's another stage class that's in the work that will include more functionality around retriable stage, cancelable stage, etc. So be on the lookout for that. Cool, so this is our random wait plugin. Let's take a look at some of these other classes like simple stage output and simple stage status. Let's see, I probably had that back here. So in Orca, all of these extensions live in the Orca API package. And that's going to be the case for all of the services. As we create extension points, they're going to go into the service-API package in the project. So if we check out source, main, blah, 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 we will see we've got this simple stage, our class that we looked at originally, and we overloaded the execute and passed in the random wait input as the type. So let's check out simple stage input. As you see, it's pretty basic. It allows to pass in a value of whatever type you want. Similar for output, it's very similar. Output also includes a simple stage status, and as you can see, there's a pared down list of the total number of statuses within Orca. So for simple stage, you can the status of your stage can either be terminated, terminal, running, succeeded, or not started. They should be pretty self-explanatory. Cool. So let's take a look at some of the other classes in this package. So we've got our random wait input, which we took a look at already. We have a random wait config, and this is what is configuring the plugin itself. So notice we have this annotation, extension configuration, and we give it a name. This will be important later as we see in the delivery steps. I didn't mention it earlier, but we also have this add extension annotation on the random wait stage itself. Cool. So we talked about the directory structure a little bit. We talked about the plugin, the stage class, the config, input, context, and output. Does anyone have questions on any of these aspects? No? All right, moving on then. Cool, so let's talk about debugging. How do you debug your plugin? you want to write a plugin and you want to test it out with your service. So we have a few different, or we have a nice way of doing that. So let's take a look. I need to open IntelliJ, apologies. All right, so this is Orca that I'm opening up, and my project is already set up to run in debug mode, but I will show you the steps necessary to do this. I also discussed the steps on the backend plugin development video. Cool. So let's talk about the process in which to debug. Cool. So I have, this is Orca. And what I've done is I've clicked on this plus sign over here and I've linked my Gradle project. I've linked my plugin itself. So if you click on the plus sign here and you choose, you open up the directory that contains your plugin and import, run, import, run, sync, Gradle, all that jazz, and pull that code in here. Another thing that you need to do is update your run configuration. So you will run from main. You need to add some VM options that specify the mode of the PF4J mode as development. And you need to include the build project step before launch. Cool. Let's see. In the PF4J stage plugin, we have a Gradle project that helps with doing releases. So let's take a look at that. In our build.gradle, we have this Spinnaker bundle, and that's what we're going to be creating as the output. We have this plugin bundler, and that's what we're going to be using to create the bundle here. So there's a task in here for the PF4J stage plugin under Spinnaker plugins, and it's release bundle. So when you run release bundle, it'll generate a plugins.ref file. So if we take a look at that file, we can see in stage plugin in the random in Orca. Let's just pop over there. And if we check out the build distributions, build temp, build libs, maybe I'll just run the command. It'll create this plugins.ref file. In the interest of not just watching me run Gradle commands, I've already generated that file and placed it in the proper location. So if you go to the Orca project, again, this is an Orca. I have generated that plugins.ref previously, and it lives, I moved it here. Again, please watch the video if you want some more info on this. So here's the plugin ref, and all this is doing is telling PF4J where all the jars and classes are, so that it can then run. Cool. So let's try it out. So as we saw before, in the random wait plugin, there's this plugin wrapper, essentially, that will, it'll call start whenever the plugins are loaded up. So let's run and debug and see how it goes. Hope everyone's day is going well so far. Do you guys have any questions that I can answer while this is starting up?
How long is your hair?
I think it goes down to my shoulders right now, maybe a little bit longer. I'm taking this staying at home time to grow it out a bit.
Thanks, Karen.
Cool, so we can see Orca is starting up. Oh, and look at that. Okay, so I actually think that running this command broke it. In the meantime, it regenerated some stuff. Awesome. So sorry about the kind of crappy demo here, but it normally works. This generated in random wait Orca in the build. There's the Orca plugin.ref file here, as we can see. And if we copy that to Orca, well, we can try and build it again and hope it works. But if not, we will just continue on with our talk here. Up next, we'll be talking about the front-end aspect of the plugins, and then we'll be talking about building and then delivering. So all of these are kind of important aspects. Cool, there's a few questions in chat. How do you release the plugin package? We'll talk about that in a little bit as part of the delivery. The plugin.ref file, does it contain reference to only one plugin or all the plugins configured? That's a great question. It is only for the plugin that you would like to debug. So we've imported the Orca plugin, the orca.plugins ref over here, and that is just for our random wait stage plugin. If we take a look at what that file looks like, it's referring to just this one plugin. So I hope that makes sense. That's for the question Gigi asked. All right, my computer's taking forever. That's correct. Orca does need to be redeployed in order to pick up plugin changes. That's exactly right. Oh, okay, so we hit this the same bug again. Apologies. I'll have to take a look at that, but it does work if you check out my video. All right, so let's talk about front-end development a little bit. We have a few different pieces here. We've got this rollup config, package JSON, and the random wait stage. So let's just take a look at what these look like in our plugin. We mentioned the directory structure a little bit earlier, and I think we can just talk about it a little bit more now. For every, let's see, for the different services, you're going to have code on different potentially. So for the random wait stage, we're going to have code on both deck and Orca that we want to modify, and we do that by putting the plugin code in different packages. And these packages include the name of the service that they should go on. So the Orca code will be going on Orca. The deck code will be going on onto deck. So if we take a look at this, deck is different as it's a React stack, React and Angular. So it's a different setup and way of building and delivering the plugin. So if we take a look at rollup config.js, this is doing a few different things. It helps like build your plugin and imports a few different helpers here. So we've got TypeScript that we've imported. We've also imported a few libraries here: Lodash, React, React DOM, and Spinnaker core. Rather, these are shared libraries that we don't have to pull in because deck already contains those. If you did pull them in, your plugin JSON will be, JavaScript will be quite a bit larger, and you would potentially have to deal with service mismatches. Cool. If we continue on, we can take a look at package.json. This should be pretty standard for most people. We pull in some dependencies here, like we mentioned earlier. Cool. Now, if we take a look at the source here, the bulk of the plugin lives in this random wait stage TSX. So this is a TypeScript file, and yeah, it's TypeScript. So this is a pretty simple stage that we're adding here. Again, this is going to be waiting for a random number of seconds. So a major component here. There's pretty nice comments here now with links, so that should help. I can leave this as an exercise to the reader. However, the key will be the how the front end is tied to the back end in Orca. The label is how the name will appear in the dropdown for the UI. A little bit of a description, and then we specify the component, which is a React component, which is down here. And then we have some execution details that are have some more information, like the title and some task details up here. Cool. So if we take a look at the component here, the random wait stage, it takes some props in, and it's pretty simple. It's a div with a label, and this is just added to the front end part of deck. Sorry. So as you add a plugin, add this plugin, when you go to the dropdown, this will appear as the stage definition. Take a look at the random wait stage index.ts. These both get like shoved together, right, as part of the build process. And you can see that we're exporting the ID of this plugin, and we give it the random weight name, as well as the component we want it to work with. Cool. So I think we covered all three of these over here. Let's go on to build. Oops, building your plugin. So we talked a little bit about the project structure. We've got the random weight deck and random weight orca. Let's talk a bit about Gradle.properties. So this project deals with a few different pieces of Spinnaker. We have the Spinnaker Gradle package we saw earlier, and this is what creates our plugin. PF4J, this is the version of PF4J that we use in Spinnaker. We have a Quark version that this is based off of, as well as an Orca version. If you guys are interested, we have some nice quality of life improvements with this repo. We have a few different build tags up over here, and these are linked to our actions. So if you check out our GitHub actions, these exist in the .github/workflows directory. What we do is every time there's a new Quark release or a new Orca release, we'll try building our plugin against those releases. And if it fails, it'll notify us in Slack. So we know to come by and fix the issue. So if one of those fails, we'll come in here, bump up the version, and fix whatever conflicts exist. Cool. Let's see, settings Gradle and then build Gradle. So settings Gradle has some information. We do need to include both of the projects that we want to be part of this plugin. Cool. Let's check out the build Gradle. Build Gradle, as we saw a little bit earlier, we add the Spinnaker Gradle project here, and we specify what the plugin information is going to be. This is needed. Cool. So let's see, we talked about settings Gradle, we talked about the build Gradle a little bit, Orca Gradle, we talked about the GitHub actions, and now let's talk about this release bundle. So if we go back to our plugin here, and we ran the release bundle earlier. So if we check out our build directory and check out our distributions. So we can see these were all just rebuilt recently, the plugininfo.json in particular. So let's take a look at that. So what this is doing is this is how you would help deliver your plugin to Spinnaker. So PF4J update knows how to read this in and then load your plugin as appropriate, I guess. So this is the ID that is contained from the script we saw earlier. So in our build Gradle, we have set this plugin ID. We set the description, provider, and version. So if we take a look over here again, we've got the ID, description, provider, and rather than version, we have a list of releases, and each of those contain information. So this is the output of your build release. Sorry, your release bundle. There's also this PF4J stage plugin zip file, and this is all of your plugin assets bundled up together. I see we're kind of running a little bit low on time, so I'm just going to speed this up a little bit. As part of the deploy, we're going to be talking about this pluginsinfo.json and how it's used in plugins.json, as well as this repositories.json. So let's take a look at our Spinnaker plugin examples repo again. So we have a lot of, our project, because it's top level project. Anyways, we have a lot of repos here that are plugins. However, this example plugin repository acts as a catalog for all of these plugins. This is an example config that you can use in order to add the PF4J plugin into your Spinnaker installation. So we're going to see how to generate this via Halyard, but just to talk through these configurations, we configure a repository and we give it an ID and a URL. So this URL points to the repositories.json file right here. It could point to this plugins.json, but for our purposes, we just wanted to align with what PF4J update was showing. So as you can see, this just contains another list of repositories here. So when a service starts up, a Spinnaker service starts up, a backend Spinnaker service starts up, it will pull down these repository.json files. It'll query all the repositories, and each of these repositories point to a plugins.json file. So if we take a look at that, that is this file right here. We can see it's a list of all of the plugins that we've defined and all the releases for those plugins. Here's our random weight plugin. And you can see we have a few different releases for it. You might notice there's a slight difference here between the plugin info.json and what we have here. It's this URL and the SHA-SUM. We have a few different things here, actually. In particular, though, the URL points to the location of the plugin bundle itself. All of this is done on GitHub, and we can see this release here in our releases list. So we've got a nice list of releases with their associated assets. One thing to note here is the random weight stage index.js. That is actually, we pulled that out of the zip file and we host it on S3. And the reason we do that is because we need to update the core settings so that Deck can pull it in. We'll talk about that in a sec as time permits. We actually don't have too much time, so let's just take a look at how we would do this with Halyard. Cool. So here I've got my Spinnaker, configs down here, and as you can see, I have these configurations already added. But if we delete them, we can say how plugins delete, and I'll delete this random weight plugin. And then I'll delete the repository as well. And then we'll just quickly go over what these commands, how they work. So we'll say plugins repository add, and we're giving it an ID, GitHub repository, and a URL. Do note that we use the raw.github user content versus just pointing to the file directly. This way we just get the contents of the file versus a HTML page containing the contents. As you can see down here, we have the repository defined now. So let's add plugins add. Let's add this Armory weight plugin. Notice that we're saying enabled is true. I do unfortunately have to specify the UI resource location as it's hosted separately. This will be changing in future versions as we improve the delivery process. I do need to specify the extensions that we are using for this plugin. as well as the version. So if I add that in here, we can see it's been added. Because I helped develop this plugin, I know that there's no default value for the constructor. And while that's unfortunate, it does highlight the fact that you cannot update these configs via Halyard. I don't think we're going to be adding that. So in order for this plugin to successfully work, I need to be deployed successfully. I need to specify a default max wait time and give it some value. Cool, and we can see those changes reflected down here. If you do not specify a version, it'll just use the latest from the repository it can find it in. We can do a how deploy apply. Nothing will happen though because this Spinnaker installation already has these configs laid down. We're a few minutes over time, so wanted to leave let people ask questions. If you guys had any questions, I'll be available today and tomorrow if you guys need any help.
I have a question. With new Spinnaker operator, and you do a lot of hell apply command, how this will be like comparing, as you know, with a Spinnaker operator, you basically have to compose this YAML file yourself.
Yes, yes, that's a very good question. I don't have a good answer for that. You're able to, if you'd like, let's see, the commands, let's see this. In our PF4J stage plugin, if you use the configurations down here, actually, if we go back to the example repository, that's a bit better. But if you just add those configurations to the service in question, these are the exact configurations that are laid down on the services. So if you just add these to your YAML files, if you're using the operator, it will deploy these to the correct service.
Oh, okay, yeah, makes sense. Like through the customize, for example, you know,
Yes.
create on the fly. I see.
Cool. Yeah, exactly. So we developed this with Halyard in mind. However, the operator seems like it's going to be the new way forward. So we're going to be there's going to be work coming to improve the delivery via the operator. So that's a great question. That should also help get rid of that UI resource location as well with dealing with the bundle.
Okay, yeah, thank you.
Any more questions? Cool. Well, I think that'll be it for today then. Please let me know if you have any questions, comments, concerns. You can reach me on open source Slack. We have a plugins channel. Or please come to the platform SIG if you guys have any suggestions. Cool. Well, thank you guys very much. Andrew, I think I'm gonna hit stop recording on this.
Sounds good.
Sweet.